For my machine learning project, I created a web app that predicts your chances of getting into your dream graduate school using only 4 features. But before I show you how it works, let me walk you through the code that developed it. So here I am on my Jupyter Notebook in VS Code. Actually, before I talk about the code, let me discuss the motivation behind working on this project. Every single year, tens of thousands of students in India apply for graduate school to US universities. Now, it can be a bit unnerving to not know where you stand as you apply to these universities. Are you going to be rejected or are you going to be accepted? This project solves that problem. Now, let me show you the code and then I'll show you how it actually solves the problem. So this is just some information about the data. But here I am loading in the necessary libraries and loading the data. So let's run this cell. Okay, we can see here the dataset has been correctly read, and we can see that the dataset contains a number of columns like serial number, GRE score, TOEFL score, university ranking, and all the rest of them. But what is really important whenever you're undertaking a machine learning project is to check if the dataset that you're working with contains any missing values. This is exactly what we're doing in this second cell. So we can see there's just zeros here, which means that this dataset does not contain any missing values. This is good news. However, I actually do not like the way the column names appear in this data frame. So I am going to do a bit of some tweaking to change the column names and also drop some unnecessary columns like this one here, serial number. This one is not needed because the data frame already provides an index for us. So we actually don't need this. So of course I created a function that tweaks the data, cleans it up, changes a few column names, and then drops that unnecessary column. So let's run that. Okay, we have run that. Now let's take a look at how the new data frame looks. Okay, so this is how the new data frame looks. As you can see, some column names have been changed. But one thing to pay attention to is that this dataset contains 500 rows. This is enough data to train our machine learning model. Also, let me take this opportunity to discuss the problem that we're trying to solve. So our target variable is going to be admit chance, which is this column. Now, what does this column show us? It shows us the likelihood of how the student is going to be accepted to the university that they apply to. So for example, this value 0.92 is like a probability value, which means there's a higher chance for this student to be accepted in whatever university they have applied to. Of course, a value of 0.73 shows that maybe the likelihood is not that high. So this is what this column tells us. Then the rest of the features pertain to the students. For example, the GRE score is like the score that they got in the exam. The TOEFL score is also an exam score. Then the university rating is the ranking of the university that you are applying to. So the lower the ranking, the tougher it is to get into that university. I suppose these ratings were based on US news or something. But yeah, so this is what is going on here. However, when you're designing something like a web app that users are going to use, you obviously don't want to have a lot of features, prompting users to input a lot of values just to produce an answer, because that would feel like they're filling out a survey. And let's be honest, no one likes to fill out surveys. So we're going to be smart on how we're going to train our model, which means that we're going to use very few features, not all of them. But how are we going to do that? Well, this is where a correlation matrix comes in. We are going to use, actually, let me produce it so that you can visualize it. So this is what a correlation matrix looks like. What we're interested in is seeing how all these other features correlate to the admit chance feature, which is our target variable. Of course, I'm not going to explain what is happening in this diagram, but one thing to pay attention to or to understand when it comes to correlation is that a correlation is always on a scale of -1 to 1. A correlation of 1 means that it is positively correlated, perfectly positively correlated, and a correlation of -1 means it is perfectly negatively correlated. Of course, in real life, you are never going to find a correlation that is exactly 1 or exactly -1. It's always within this scale range. But how are we going to choose what features to use in our model? So this is where I made the decision to only pick the columns or the features that have a correlation value of 0.69 or higher. So when we run this function, it is going to pick those columns for us which have this correlation value of 0.69 or higher. So let's run that. And sure enough, we get the names of the features that have that correlation value, which are GRE score, the TOEFL score, the university rating, and the college GPA. Okay, so now it is time to train the model. Of course, my algorithm of choice is random forest. I actually tested XGBoost, and the results it produced were not as good as those produced by random forest. So that is why I'm going with random forest. But here's one thing to pay attention to. The features that we got from the correlation metrics are going to be our independent variables. Then the admit chance is going to be our dependent variable, something that we're trying to predict. And another thing to pay attention to is how I partitioned the data set. So 20% was used for the test size and 80% was used for the train size. Then of course this is just some hyperparameter tuning and everything. Then the measure that we're going to use to see how well our model performs is the mean squared error, or the root mean squared error, which is just the square root of the mean squared error. So let's run this model and see what the results are. Okay, so the results are actually good. They're actually very good. So what do these results mean? Well, let's focus on the root mean squared error. What does this mean? It basically means the variation of the predicted values that our model produces compared to the actual values. So when we see this 0.065, it shows that there's a 6% variation in the values produced by the model compared to the actual values. So 6% variation is not that much, which means that there isn't the discrepancy is not that big. We can trust that the model is doing a good job at predicting the value that we're trying to predict. Okay, now that we're satisfied with how the model works, let's export this model as a joblib. So let's do that. Okay, now that we've done that, it is time to test how the model works. So I am going to click, because I've already hosted this web app on the web. So let us click on this link and see how it actually works. Okay, so it is loading. Okay, it has loaded. Now, just to see how well it performs, let's go back to the Jupyter Notebook and pick maybe the first row values. So here I am going to pick this and see how well it produces this value. So let's see how good our model is. Let me just take note of those values so that I don't switch from screen to screen. All right, I have taken note of the values. Let me go back to the web app and let's try that. So the GRE score for this student is 337 and the TOEFL score is 118. These are actually good scores, by the way. Then the university rating is 4. Suppose this is like one of those Ivy League universities, or Stanford, something like that. But anyway, what about their college GPA? So the student's college GPA is 9.64, which is actually very good, by the way. So let's do the prediction. Okay. Alright, so it has predicted a 94% chance of this student getting into the university that they apply to. So this is of course not surprising, because as I said, these scores that the student has are very good and the GPA is exceptional. So it is not unlikely that they have this chance of getting into the university that they have applied for. But actually, let's see what the actual value was in the dataset. So here we have 94.20. What about in the dataset? What does it say? It was 92. So not too bad. Not too bad. The model works well. Yeah, so this is it. Thank you for watching. If you want to reproduce this work, I will give you a link to my GitHub repo that you can clone and work on. Perhaps you can even improve the model if you want. But I just wanted to show you like how to train the model and actually create a web app that does the work that your model is intended to do. Thank you so much. Until next time, goodbye.